Welcome to Speed Physics. Introducing the SI unit of length, the metre. So what is length? Couched in physics jargon, it is the quantitative measure of extension in one direction. Put another way, length is the distance measured from a reference point to any given point in a particular direction. Though to be accurate, when we bring in direction, we are talking about displacement, which is a vector quantity, much like comparing velocity to speed. More about vectors and their friends the scalars in another video. Today we'll just be talking about length and not dwelling on the direction part. The SI base unit of length is the metre, or spelled meter, M-E-T-E-R, in the USA. The metre was originally defined as 1/10 millionth, that's 10 to the power minus 7, of the distance between the North Pole and the equator. This was realised as a metal rod made from platinum iridium alloy with two marks on it, 1 metre apart. Why this special alloy, you may ask? Well, to keep expansion to a minimum. Too much expansion would mean a metre being longer when it's hot and shorter when it's cold. At that time, the temperature was controlled to some extent and prevented from fluctuating too much, but this situation was far from perfect. So a new way was found, using the universal constant, the speed of light, and the unit of time, the second. Now, since the speed of light is just less than 300 million meters per second, it follows that in 300 millionths of a second, it will have travelled 1 metre. So, that is that, you may think. Well, no. Here's a few things to think about. Don't get me wrong, for nearly all the problems we will come across, our base unit, the metre, will serve us just fine. It will stay constant. Well, relativity theory, remember that guy Einstein, tells us something different. It says that when an object approaches the speed of light to an observer, the object appears shortened in the direction it is travelling. Essentially, a moving metre gets shorter. The other little fly in the ointment concerns the expansion of the universe. I'm sure we've all heard of the Big Bang Theory. Well, it is a poorly understood concept. The thing is that not just all the matter in the universe came into being in the Big Bang. Space and time were created at the same time. I agree. This is quite a hard one to get your head around. Anyway, space began inflating. Yes, space itself was expanding, and still is. We live in an expanding universe, and here's the proof. The wavelength of gamma ray light emitted from the Big Bang is now detectable in the microwave region. The light rays have been stretched out. Over 13.7 billion years, the lengths have changed. How can anyone think that physics is boring? Not as though that will affect us. Even over the period of mankind's existence, which is puny against the edge of the universe, any increase in length is negligible and probably not measurable. Okay, so the unit of length is the metre. Let's take a look at some lengths to get some perspective on this. 1 kilometre, 10 soccer pictures. 1 metre, the length of a walking stick. 1 centimetre, the width of a pencil. 1 millimetre, the width of a pinhead. 1 micrometre, the length of a bacteria. 1 nanometre, the width of a strand of DNA. Now let's look at these units in more detail. Unit kilometre, unit symbol km, length 1000 metres, standard form 10 to the power 3 metres. Unit the decimetre, unit symbol dm, length 1/10 of a metre, standard form 10 to the power minus 1 of a metre. Unit the centimetre, unit symbol cm, length 1/100th of a metre, standard form 10 to the power minus 2 of a metre. Unit the millimetre, unit symbol mm, length 1/1000th of a metre, standard form 10 to the power minus 3 of a metre. Unit the micrometre or micron, unit symbol μm, length 1/millionth of a metre, standard form 10 to the power minus 6 of a metre. Unit the nanometre, unit symbol nm, length 1,000 millionth of a metre, standard form 10 to the power minus 9 of a metre. Now we can go smaller than this, much smaller. Theoretical physicists use a unit called the Planck length, LP, small case l, subscript capital P. This is so small it can't be measured at present. You heard me. We don't yet have the technology to probe that small. In fact, the Planck length may never be measured. It is considered to be the smallest length that can exist and is estimated as 10 to the power minus 20 the diameter of a proton. To put another complexion on this weird concept, in string theory, the Planck length is of the order of vibrating strings that make up elementary particles. Needless to say, in the future, string theory is definitely a region for speed physics to visit. On a parting note, Einstein once said, "Logic will get you from A to B, imagination will take you everywhere." Remember, if you subscribe to the channel, you will be among the first to view any video release. Speed Physics, your gateway to the easy and not so easy parts of physics.